So we'll spend maybe 20, 25 minutes on this, and then we'll get into more U substitution and area between curves. I did take a look at what's in the sections on logarithms and exponential functions and also the inverse trig. I'll talk about it for 2 minutes. We've covered most of what you need out of those sections. They're very short. You can go ahead and do them. They're formula driven, right? And I'll tell you which formulas I expect you to know. So we're looking at 15 and 16 out of 5.1. So, oh yes, okay. Yeah, this is actually a kind of ingenious problem, but how you do it isn't always very clear. So what you're supposed to be doing is finding a lowest possible value for the area and a highest possible value for the area, right? Like a lower limit and an upper limit on the area. What they want you to do is look inside the blue shape and find all of these little gray squares that are completely contained inside the blue shape. Are there any? Did I go over this in this class? Okay, that was a new class. There are none, right? 0? Everybody buy that? You don't have any that are contained in there, right? Do you have any partial squares that are contained in here? And a partial square means even if it just barely clips the corner, that's area, you got to include it. So how many partial squares? Now let's use symmetry, like in the odd even section, let's use symmetry to shorten our work. This is symmetric both with respect to the y, meaning it's even, and it's symmetric with respect to the x, meaning it is also odd, right? So for symmetry, you either have no symmetry, which most functions don't. You have y-axis symmetry because you fold on the y. You have origin symmetry, which means you have to fold twice, right? Or you have both of them, right? You either have no symmetry, one type, or you got them both, right? Even and odd. Okay. Now, if we're looking at this, even the x-axis, y-axis, and origin, you either have one, all three, or none. Those are your choices. Okay, so you can't have just two. So if we're looking at it, how many partial squares are touched in quadrant 1? I'm thinking 5. Is that what you got? Multiply by 4 for the 4 quadrants. This is sort of a boundary in between, right? For an upper bound, you're going to add those two numbers together. So what do you get? 20. That's literally what they're asking you to do. On the next problem, if you scroll it up, it's the same picture, but this time they've changed the scale. They didn't change the picture, they changed the scale. So instead of going up to 1, they made our little grid smaller. So, but our grids are not one wide like they were on the one above. These are 0.5 by 0.5. So, in other words, how many of these would it take to make up one square of the same size of the previous one? This is where you have to be careful. Our intuition to say twice is because 0.5 times 2 is 1. But how many would you need to make a 1 by 1 square? 4, right? 2 across and 2 high. So you need 4. So we're going to repeat the process, and you're going to count the whole squares. I'm just going to do quadrant 1 and multiply by 4 and then divide by 4, which basically means just count the squares. So I've got how many complete gray squares contained in quadrant 1? What'd you get? I got 9. Okay? So I've 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so if I have 9, then multiplying by 4 and dividing by 4, right? Why would I multiply by 4? 4 quadrants, right? And why would I divide by 4? Because they changed the scale, right? So this is 9 now. my lower estimate is 9, right? What partial squares got touched in quadrant 1? What'd you get? 11. I had to sneeze. Okay, this barely clips the corner, right? So it counts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I missed one. Where'd it go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right? Times 4 divided by 4 gives me 11. And my estimate is again 20. All right? Just a different way of doing it. Kind of an ingenious way of estimating area inside of a curve. Right? Okay. And then out of 5, 2, we had 9, 13, and 14, especially 13. So let's see what those look like. What's to do here? Estimate the area under the graph by using the left endpoints to create 5 rectangles, find their total area, find the area using the right, and then estimate the area by finding the average value of the left and the right endpoints. What's the average value of the left and the right endpoints? AKA? Come on. That's just the midpoint, right? If you average 2 points, you're talking about the point halfway in between them, right? So averaging the left and right will just be the midpoint. I don't see a graph. Oh, piecewise linear graph that passes through the list of points in the given interval. So between 0 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5. Hopefully I don't have to go up too high. Nope, good. Okay. So 0, 1 would be, don't go 0, go to 1. 1, 2 is here, so that's a straight line segment. 2, 2 is here, so that goes horizontally across. 4, 3 is here, so that's a straight line to there. 7, 5 would be here, so that's a straight line. And 9, 5 is also here. And they want the area between the interval from 0 to 9. So you're talking about this region right here. Why does the x-axis get to be a boundary? It always gets to be a boundary unless you're integrating with respect to y. It's always between the axis and the function. That's where the area is found. So what I would do if I were going to do this one, first thing I would do would be to cut this at a height of 1. This is just using geometry. There's no calculus here. Well, the idea is calculus, but there's no real calculus. That is 1 wide and 9 tall, so what's the area? 9. Yeah, I mean, you can compute the exact area. What they're asking you to do, though, is find the left Riemann sum, right Riemann sum, and the midpoint. So if you're using the left endpoint, and did it tell us 5 rectangles? Ew, that's nasty. Okay, so b minus a over n would give me, how wide should each one be? 1.8. And that's what's going to make this one hard. It's just a lot of work.
I did this one and I just did it at the end point of each thing, so they're not equal length.
Right.
Yeah, but it got the ratings on both sides.
Really?
I did.
You did too? So we can just ignore the answers and just compute it. Is that what you're saying?
All I'm saying is that I didn't do b minus a divided by n. I didn't find the delta x.
You didn't find the delta x?
No.
I drew it and then did it individually based on individual length and width of the box.
Yeah.
You should. Why should all of these methods give you the same answer? They should. Why?
Because because I did it both ways, and when I did it that way, it didn't.
Oh, when you did it this way, it didn't work?
Yeah.
Really? It should. In this case, I think it's working the way you were doing it because it's geometric. They're all geometric shapes. They're not curved. If they were curved, I don't think that would work. But because they're all straight line segments, I think it would work whichever way you do it. But this is basically the way you're supposed to approach it, right? I'm not going to give you one on an exam where your delta x is 1.8. That's not going to happen, all right? Your delta x is going to be something simple that you can compute easily by hand, as in 1 or 2, okay? That's pretty much it, right? I can't give you 3 because then when you plug it into the function, the numbers start blowing up and they get too large, right? So I'm going to basically give you something between 1 and 2. This is basically what they're having you do, okay? All right. What was the next one that you wanted? 13 and 14? Let's take a look at 13. Fast. So 13 says find the average value of this between 0 and 3. Okay, so my function is f of x is the square root of 9 minus x squared. Remember I said you need to start recognizing these? This is coming back again the last week of the semester. We'll be studying conic sections. This is a circle. Which half of the circle is it? How do you know it's the top half? It's positive. If it were the bottom half, you'd have to have a negative out front, right? You can recognize it by squaring both sides and then moving the variables together on the same side. Which basically means it's a circle, the center's at the origin, the radius is 3, all right? So remember your formula is x minus h squared plus y minus k squared equals r squared. Not r, but r squared. So I have a circle. It is centered at the origin, and the radius is 3. Oh, I'm not very good at drawing semicircles. Okay, there we go. And they want the average value. Average value is the height you would use between, and which one are we doing? 0 to 3? So somewhere between 0 and 3, if I'm looking at just this area right there, somewhere between 0 and 3, there's a y value where the area under that rectangle is exactly the same area as is under the quarter circle, right? And this is the average value. And they want us to figure out probably next, yep, where is that? What x coordinate has that y value as its function value, all right? So there's a formula for that, but the formula makes sense. The formula basically is we're looking for f average, right? That's a y value, and this is going to be f of c, whatever it is. And we're going to take the area, which is going to go between 0 and 3 of the square root of 9 minus x squared dx. That's the area under the curve, right? Which, by the definition of the average value, is also the area of this rectangle. So if I want the height, what do I do to the area to get the height of the box? Take the area and divide by the length. And what is the length in this case? 3 minus 0. That's 1 over b minus a times the integral, all right? This is basically area divided by length equals height. That's what you have. The height is the area divided by the length. Okay. We happen to know what the area of a quarter circle is because we have the formula for a circle. What's the area of a circle? Pi r squared. And if I'm going to do a quarter circle, what do I need to do to it? So I'm going to take pi r squared and divide by 4. r squared is 9, that's in the formula. So I have 9 pi over 4, or you could write it as 2.25 pi, whichever one you prefer. I only use decimals if they're precise. If they repeat, I don't use them, okay? So you can do 9 pi over 4, that's your area, and then you need to divide it by 3. So what is the average height that we're looking for? 1/3 of 9 pi divided by 4 equals 3 pi over 4. That's precise. Now pi is about 3.14-ish. So 3 times that would be about 9.5, right? Roughly. And if I take 9.5 roughly and I divide by 4, I'll get about, I think, what did I say? 9 divided by 4. I think it's about, I've just lost it again, 2.4, something like that. You can work it out, but that's about where it is, about 2.4. Oh, I'm a little off. The real value's over here somewhere. Okay, the real one is over there somewhere. Okay, the height wise. No, I guess I'm pretty close. Actually, I'm pretty dead on, aren't I? Okay, that's the average value. How do you find the C that has that? How do I find my C? This is the Y value. Set it equal to the function and solve for C. So this is going to give me the square root of 9 minus C squared equals 3 pi divided by 4. Square both sides to get rid of the radical. 9 minus C squared equals 9 pi squared divided by 16. What happens next? I would probably move C squared over here and move that over there. And that would be my value, whatever that turns out to be. That's going to be, let's see, 9 minus 9 pi squared divided by 16. And this is C squared, so what do I have to do to it? Take the square root, but I'm looking for the one between 0 and 3, which means I'm looking for the positive root. Now, you could simplify it a little bit. 9's a common factor. You could pull the 9 out. Why would you do that? Why pull the 9 out? It's a perfect square. If it weren't a perfect square, I wouldn't bother. But it is a perfect square. So I'm going to pull it out, and that would give me 3 square roots of 1 minus pi squared. Can I do the pi squared? Do not follow me down the rabbit hole. Does that equal the square root of 9 minus the square root of 4? No. So can I undo the square on pi? No. Why not? Subtracted. What can you split radicals across? Multiplication and division. That's it. All right, so you can't do any more, and then you should do the square root of 16, which would give you 4. That's the exact value, which based on my picture, I was pretty spot on, which is shocking given how little spatial ability I have. I'm not exaggerating. I have the lowest grade in my class on that ability when we took our aptitude test in high school. I didn't want anybody to see my score. I think it was like a 30 out of 100. It basically said, you will not be an architect. I was like, okay, I'm good with that. Yeah. Very little spatial ability. Okay. Next one is probably similar. Yes, this one is similar. This one, though, the difficulty is graphing and finding the equation. So it's not the concept, it's the equation. It is, again, algebra rearing its very ugly head. Your function, which of course is just your y value, is 27 minus 3 absolute value of x, and you're supposed to go between -9 and 9. Does everybody see that? Okay. You're looking for the average value. Now, we're going to take the picture off so you can see a little more clearly. There are two basic ways of doing it. One is algebraic, one's geometric. All right? I'll give you both. You can pick the one.
We did this one yesterday.
Did I do this one in here? Okay, then I'm not doing it again. Okay, so, and I did record yesterday, so you can watch it there, and they're posted. Okay, I knew I'd done it. I couldn't remember if I'd done it in here or not. So what's the next one?
Number 9.
9 and 19 for sure, and then we'll probably move on. Okay, so let's see what we've got. 9 and 19. Now, I did post up here that there are a few out of 5.3, and there could be another one that I've just missed that should not have been on this homework set, because in 5.3 you had not yet learned U substitution, and they required you to do U substitution. So as a department, we will be working on the homework set over the holidays to try to get these problems out of there, because they shouldn't be in this section. You haven't learned it yet. Okay, so on this one, use the fundamental theorem of calculus part 2. Okay, that's pretty straightforward. 1 minus 7. Instead of writing the square root of t, write t to the 1/2. Why would you write t to the 1/2 instead of square root of t? Power rule. When you undo the derivative, you frequently use the power rule, so it's harder in the radical form. It's easier in the rational power notation. Okay, so to do this one, the first thing I'm going to do is I'm going to split it up. You have one term in the denominator, a monomial. There's no addition or subtraction in the denominator. When you have that, the easiest way to go is split it. This becomes 1 over t squared minus 7t to the 1/2 over t squared dt. Then you're going to lift the denominator 1 to the numerator so you can apply the power rule. So that's t to the -2. These have the same base, so you subtract the powers. 1/2 minus 2 is a -1 or -1.5. or -3/2. So this is minus 7t to the -3/2. If you're not sure you can do that in your head, don't do it in your head. Write it down. 2 is 4/2. Just write it. It is so much faster than sitting there and trying to make sure you're not messing up. Okay. So you get minus 3/2, and then you have the differential dt. And then undoing the power rule, I would get add 1 gives me a -1, divide by a -1 just changes the sign. And then I've got minus 7, add 1 to -3/2, so it becomes -1/2. And then dividing by -1/2, you multiply by the reciprocal, which is a -2 over 1. And this has to be evaluated between 4 and 7. So I'm going to rewrite it in a better form. So I have -1 over t minus, let's see, what do I have? Oh, I've got a double negative, so it's plus, wait, I've got 7 times 2, so 14. And the t goes to the bottom, and the 1/2 power, now I would probably put the radical back in, because when I'm plugging in numbers, it's easier to do it with the radical form than the 1/2 power form. And then this goes between 4 and 7. All right. Now, on this one, I don't know that there's any advantage to switching the limits of integration to change the signs, because I have one negative and one positive. It's not going to make a whole lot of difference. It would get the negative in a different spot, but plugging it in, I would have -1 over 7 plus 14 over the square root of 7 minus everything that follows the minus from the lower limit of integration goes in brackets with the subtraction outside. This is the most dangerous place in the entire integration, given if you know the antiderivative. Then I'm going to plug in the 4, minus 1 over 4, plus 14 over the square root of 4. The danger is those negatives, right? So negative 1 over 7. And, I mean, you could rationalize that, but I don't know that you're going to gain a lot. You're not going to be able to combine the numerators if you do. A double negative makes this plus 1/4. The square root of 4, that is a 2. What is 14 divided by 2? 7. I might actually draw through the whole thing and put a 7. And then I've got a negative times a positive, so it becomes minus 7. And now I've got to have common denominators of what, 28? So this is going to be a negative 4/28. Pull this to the front, plus 7/28 minus, I don't know, what's 28 times 7? 56, 5, 196. Somebody check, but I think that's right. I just got a common denominator, plus 14 over the square root of 7, which would be 3. I'm getting negative 193 over 28 plus 14 over the square root of 7, whatever that is. Just algebra. Lots of it.
Web work takes the third answer.
I know what work does, but I don't, right? If you give me that, what are you going to lose on the test?
I don't know how many points.
Points. Yes, they add up. Don't make me do your algebra arithmetic. I will tell you, this is your chance to really get that algebra down. Go ahead and force yourself to go through it and see if you can get down to the end. It is where you learn it. Okay. And we'll take a quick look at 19. I don't know that we'll have time to work all the way through it, but I can at least set it up. Oh yeah. This actually shouldn't be that bad. So this one talks about a car driving down a road in such a way that they give us the velocity equation. All right? And they want to find the car's average velocity. Okay. Average velocity. So basically all they're saying is, this is f of x, go find the average value between 3 and 5. That's it. So what's your formula for average value? 1 over the length, so b minus a, times the integral from a to b, the area, of v of t dt. That's what you're doing, basically. Okay. So this is going to give us 1 over 5 minus 3, the integral from 5 to 3 of 3t to the 1/2 plus 4 dt, which is 1/2. Integrating this back part would give me 3t to the 3/2 times 2/3, so that's good because the 3's will cancel, plus 4t between, oops, I have my things backwards, 3 and 5. 3 and 5. So the 3's cancel. I can distribute the 1/2 before I evaluate. So this is the square root of t cubed plus, because the 2's canceled and the 3's canceled, and then half of 4 is 2t, and this is between 3 and 5. So plugging in, if I did 5 cubed under a square root, I would get 1 5 out, but 1 would be left under the square root, plus 10 minus, now plug in the 3's. If I plug in 3 cubed, one of them pops out, 1 stays behind, plus 6. And then down here, this would give me minus 6. So 4 plus 5 squared root of 5 minus 3 squared root of 3. Yeah? Is it starting to fall into place a little bit, I hope? Does everybody see what I did? I think what's holding most of you up is not the calculus, it's the algebra, right? It's simplifying some of this stuff. All right. So that's most of what you have questions about. Let's go ahead and take a look at some new stuff.